Welcome to Environ Presents, an introduction to cosmetic chemistry and the science of ingredients. We'll start with our vitamin A. Vitamin A is known to nourish the skin. In other words, vitamin A is food for the skin. Dr. Des Fernandez researched the actions of vitamin A, C, and antioxidants firstly on himself and then on human trialists in order to protect and maintain healthy skin. Environ has pioneered the use of vitamin A. We use dosages in a progressive system in order to stimulate vitamin A receptor sites. One would progress from a low dosage of vitamin A with the ultimate goal of getting to the highest possible dose, and this will vary from client to client. There are two main forms of vitamin A. The animal form is called the retinoids, and the plant form is called the carotenoids. Beta-carotene in food is converted to vitamin A by absorption from the small intestine to the lymphatic system and transported and stored in the liver as retinol palmitate until required. It is delivered to the cells of the skin by conversion into retinol and attached to proteins in the bloodstream. Upon arrival in the extracellular spaces of the dermis or epidermis, it reverts to retinol palmitate so it can enter the cell wall via special retinol palmitate receptors. As it moves through the cell membrane, it's further converted into retinol and finally into retinoic acid by the mitochondria. There are a few forms of vitamin A, and we'll briefly discuss the acid, alcohol, and fat forms. The acid form of vitamin A is best known as retinoic acid, or retin-A. Environ does not use this form. Retinol is the alcohol version of vitamin A, and this is generally accepted as the basic form of vitamin A from a chemical point of view. Retinol is very sensitive to light, air, and water, and thus retinol has a limited shelf life. The derivatives of retinol in the fat or ester form are called retinol palmitate and retinol acetate. They are milder, though still active, and easier to tolerate by the skin. They are actually the forms in which vitamin A is stored in the liver. Retinol acetate is more active than retinol palmitate. Environ generally uses the ester form, for example, retinol palmitate and retinol acetate, but we also use retinol and beta-carotene, which help to prevent and reverse established photoaging. Retinoids are very active and easily degraded by exposure to light, heat, and air, and moisture as well. This means that, when used in products, they must be made under very controlled circumstances and protected once in their containers. For this reason, Environ does not use conventional glass jars with wide lids, but instead opts for the collapsible aluminum laminated tubes or airless pumps to protect the vitamins from light and air. Retinol palmitate was the first form of vitamin A scientifically proven to be effective in rejuvenating mature skin. This research work was done in 1955. Presumably, people tried to use it only for a short while and were discouraged by the very slow changes experienced. Retinol palmitate is converted to retinol and retinoic acid once it has entered the cell nucleus. This accounts for most of its effects. The palmitate moiety of the molecule seems to have a very important role. It is a high-energy molecule that is highly desirable to cells, and they easily absorb it from the interstitial fluid into the intracellular compartment. The energy from palmitate can be used in the conversion of vitamin A into the various isomers of retinoic acid. Vitamin B. Vitamin B3 as niacinamide is one of the water-soluble B complex vitamins. Niacin or nicotinic acid is also known as vitamin B3. It is required for cell respiration, which helps the release of energy and metabolism of carbohydrates, fats, and proteins, proper circulation, and healthy skin. The inhibition of melanosome transfer from the melanocyte to the keratinocyte, where melanin is changed to black-brown color. The importance of this is that it can reduce pigment blemishes, controlling uneven skin tone and blemishes, increasing hydration, and assisting in softening fine lines. Rich sources of niacinamide can be found in the liver, chicken, peanuts, pork, salmon, sunflower seeds, tuna, turkey, and veal. Vitamin B, as provitamin B5, this is used in a base to boost the waterproofing barrier of the skin. to assist in controlling free radicals, and to reduce the chances of follicular obstruction. Panthenol is known to have a soothing and smoothing effect on the skin. Vitamin B6 is a colorless or white crystalline powder added to evaporated milk in infants' foods. It is present in many foods, especially yeast, liver, and cereals. It is a coenzyme that helps the metabolism of amino acids and fats. Vitamin B6 allows for normal red blood cell formation, balances hormones, and strengthens the immune system. Its benefits are maximized when taken as an oral supplement. Vitamin B12. It is classed among the water-soluble vitamins, though it's not easily soluble in water. As the name implies, cobalt is an essential part of this vitamin, which acts as a cofactor in metabolism. It is also important in DNA synthesis. Vitamin B12 in our diet is obtained only through animal products. Vitamin B12 is absorbed through the bowel, but its so-called intrinsic factor is required for its absorption. Intrinsic factor is produced in the stomach as we get older, and we produce less intrinsic factors, as results in less vitamin B12 absorption. To keep tissues as healthy as possible, vitamin B12 should be supplemented regularly. B12 can be absorbed through the mouth, and in this case, intrinsic factor is not required. However, the vitamin has to be kept in the mouth for as long as possible to ensure absorption. Otherwise, the swallowed B12 can only be absorbed with the intrinsic factor. Topically, B12 enhances the regrowth of hair on the scalp. It is also known to energize skin cells, which makes them function better. Vitamin C, as ascorbic acid, cannot easily pass through the horny layer, which is a lipid-based layer and repels water-based molecules. Moreover, whatever ascorbic acid gets through into the lower levels of the skin is not easily absorbed into the cells themselves. This is why one is to rely on more lipid-soluble versions of vitamin C, as an example, ascorbyl tetraisoparmetate, which is more easily absorbed and penetrates into the skin cells and then converted back into active ascorbic acid in the cytoplasm of the cell. Magnesium ascorbyl phosphate and sodium ascorbyl phosphate. Another way to get the ascorbic acid into the cell itself is to combine it with another molecule that is selectively taken into the cell. An example of this form of vitamin C is magnesium or sodium ascorbyl phosphate, which is also water soluble, but it's taken up into cells much more efficiently. Inside the cells, the vitamin C compound is easily converted into ascorbic acid, phosphate, and magnesium or sodium. Solutions of ascorbyl phosphate are also more stable than conventional ascorbic acid and can last up to 200 days before there is any appreciable loss of activity. Lower concentrations, compared to ascorbic acid, are required to get the same amount of ascorbic acid into the cell itself. Ascorbic acid and ascorbyl phosphate salts are both useful and have similar results, but have a different client profile. People with sensitive skins cannot use ascorbic acid, and so Environ uses magnesium ascorbyl phosphate products and ascorbyl tetraisoparmetate for them. People with pigmentation problems should avoid any product that peels the skin significantly. Ascorbyl tetraisoparmetate is the oil-soluble and extremely stable form of vitamin C. There are 4 molecules of palmitic acid attached to the ascorbic acid molecule, to form ascorbyl tetraisoparmetate. The palmitic acid molecule is about the same weight as the ascorbic acid molecule, so one can see that vitamin C consists of only about 20% of this large molecule. However, with only tiny amounts of vitamin C, this oil-soluble form passes easily through the horny layer and enters the cell wall with great ease. You can get up to 10 times more active vitamin C into the skin cell itself. As a result, there's more effective control of melanin formation, greater collagen deposition, and more efficient antioxidant protection. Our experience with this wonderful molecule makes us believe that we have entered a new era in vitamin C treatments for the skin. However, bear in mind that this vitamin C is oil-soluble, so it cannot be used for iontophoresis. Combined with vitamin A, we have seen rapid smoothing without any irritation and lightening of the skin. Of course, it is also combined with a wide antioxidant brigade and effective UVA protection. Uneven skin tone will improve. Environ has pioneered in using ascorbyl tetraisoparmetate. This must not be confused with ascorbyl palmitate or ascorbyl dipalmitate, which has been used in low doses by many companies. Ascorbyl palmitate has the advantage that it is oil soluble, but unfortunately, it is difficult to include in cosmetic formulations in high doses. For high doses, alcohol has to be employed, and that limits the use. The fact remains that not nearly as much vitamin C is achieved inside the cell as with the ascorbyl tetraisopalmitate. Vitamin E is normally found in the skin and is an extremely effective lipid-soluble antioxidant in the lipid or oily phase of the skin cell membranes. The myth about it being useful for scars is exactly that, a myth with no substantiation, no evidence, and no proof. It is well known that vitamin E enhances the effects of sunblocks and keeps the skin safer. Surfers often apply vitamin E oil to sun-exposed areas to reduce sunburn. This vitamin protects collagen, and studies indicate that it can improve the appearance of the skin when supplied in high doses. However, high doses are difficult to stabilize in most cosmetic preparations. Biochemically, it has limited function, if any, except as a lipid-based antioxidant. In this regard, it's extremely important, very powerful, and essential. Its main weakness is that it is easily inactivated while protecting lipoproteins, and vitamin C is essential for recycling it back into active vitamin E. Vitamin E is part of the network antioxidants consisting of vitamin C, vitamin E, glutathione, alpha-lipoic acid, and coenzyme Q10. In nature, the active form of vitamin E is labeled as D-alpha tocopherol. However, naturally derived vitamin E is hardly ever used in cosmetics, and so we have to rely on synthetic vitamin E. This is made of D-alpha tocopherol and therefore consists of both the right-hand and the left-hand version of vitamin E. L-tocopherol acetate does not have any activity in the body because it does not fit the molecules of the body and cannot interact. Only D-alpha tocopherol can make the correct fit, just like left and right-handed gloves can only be used for the appropriate hand. By carefully separating the D-alpha tocopherol from the mixture, natural synthetic vitamin E can be obtained. This is in nature identical and is the only form of vitamin E that can function. Lipocomin 6 is a synthetic vitamin E analog. It is a high-potency antioxidant and free radical scavenger that inhibits lipid peroxidation. It has specific protective qualities against nitrogen-based free radicals. Free radical quenchers are used to counteract the effects of free radicals formed from sun exposure or from natural processes. The antioxidants used are natural vitamin C, E, B5, beta-carotene, and antioxidant plant extract. As an example, rooibos, honeybush, green tea, lycopene, rosemary leaf extract, witch hazel, resveratrol, lutein, and many others. Beta-carotene and other carotenoids and flavonoids. Beta-carotene is a precursor of vitamin A and belongs to the carotenoid group of chemicals. They are yellow, orange, or red and are almost universally distributed in living matter. When we ingest certain carotenes, we are able to synthesize vitamin A in our body. Beta-carotene is one of the safest forms of vitamin A and also has an important role as an antioxidant. It is one of the most effective antioxidants and is reliably stable. One molecule of beta-carotene can counteract a vast number of free radicals. We are able to make as much vitamin A as we need from beta-carotene and not cause any vitamin A toxicity. Alpha-carotene has similar effects to beta-carotenes, however, only adequate, not ideal levels of vitamin A are produced. We should not forget about lutein, lycopene, which are gaining more attention as we begin to understand their activities. They have been even more important than we presently suspected. They are found in very low levels but seem to be extremely active. They are non-vitamin A forming carotenoids but are essential for skin. Lycopene is an extremely powerful antioxidant. Natural lycopene derived from tomatoes contains photin and phytofluene, both of which have skin lightening effects and offer an anti-inflammatory protection against UV and oxidative damage that can lead to premature aging. Phytine and phytofluorine are able to protect DNA from UV and free radical damage, as well as collagen from degradation. Carotenoids may have an important part to play in the conversion and prevention of skin cancer. The controversy about beta-carotene promoting lung cancer concern only its use when taken orally. When applied to the skin, beta-carotene is placed directly where it's needed and constantly used up. Carotenoids are important in the skin because they reduce the effects of sun damage. Asians naturally have high levels of beta-carotene in their skin, which may be the reason why their skin appears more yellow and also looks younger. The antioxidant vitamins seem to be intertwined in their action, and they should be used together to get the best effects. Lutein is a lipophilic extracted carotenoid from marigolds, which gives them the cream or yellowish coloring. It is an antioxidant that filters out harmful, visible, high-energy blue light that is present in our everyday environment. We know that blue light has destructive effects on cells and DNA. Dr. Fernandez has a personal belief that blue light is involved in melasma. It also significantly reduces free radical activity. Selenium is a coenzyme in a chemical process that is important for removing free radicals. It is not easily absorbed by the skin when applied topically and is generally used as a dietary supplement. It has been shown that skin cancer is more common in people who have low dietary intakes of selenium. Alpha-lipoic acid was once considered a vitamin, but humans are able to make small amounts of alpha-lipoic acid, so it cannot be classified as a vitamin. The active version is dihydroalpha-lipoic acid, which has the ability to scavenge free radicals in both water and oil phases of the cell. It is extremely powerful and is part of the special network of antioxidants. Alpha-lipoic acid especially recycles vitamin E and prevents vitamin E deficiency. Alpha-lipoic acid promotes production of glutathione and thereby helps to recycle vitamin C. Coenzyme Q10 is one of life's most essential biochemicals, hence its other chemical name of ubiquinone. It is a coenzyme of a special type of quinone. The functions of coenzyme Q10 are mainly in the mitochondria, where enormous quantities of free radicals are produced as part of the energy-creating process of the cells. Coenzyme Q10 has become a valued dietary supplement as well as a useful topical ingredient because of its ability to transfer electrons. It therefore acts as an antioxidant, and young people are able to take Q10 from lower numbered ubiquinones such as Q6 or Q8. On the other hand, ill and elderly people may not be able to make enough, so thus Q10 becomes a vitamin to supplement in later life and during illness. Supplementation of Q10 may help migraines. It is also being investigated as a treatment for breast cancer. Recent studies have shown the antioxidant properties of coenzyme Q10 benefit the body and the brain. Some of these studies indicate that coenzyme Q10 protects the brain from Parkinson's and from the damaging side effects of a stroke. Idabuquinone is the synthetic cousin of coenzyme Q10. Glutathione. Glutathione is one of the most important antioxidants naturally found in the body. It is a cofactor for the enzyme glutathione peroxidase and helps to reduce homocysteine. Glutathione has many important activities and can only be produced in the body. It is essential for recycling vitamin C when vitamin C becomes a free radical after detoxifying a more aggressive free radical. It cannot be supplied topically or by mouth. And the only way to encourage the formation of glutathione may be supplying the precursor N-acetylcysteine. Witch hazel is a natural astringent that is also known to reduce inflammation and has good antioxidant properties to help fight the effects of free radicals. This is an exciting molecule that has become an essential part of the aging program for skin and body. Resveratrol exists in both cis and trans isomers, but mainly as trans resveratrol, which is the biologically active isomer. Resveratrol has been known to be cancer-preventing agent as well as a result of the expression of various growth factors, some of which are expressed by the keratinocytes. Topical application of resveratrol has been shown to accelerate wound repair and greater epithelial growth, collagen and elastin synthesis, improve histological architecture of the skin, lighten skin color and improve uneven skin tone, exert its effects on the melanocyte by reducing the activity of genes that promote the formation of the enzyme tyrosinase, and as a result, reducing our ability to tan skin. It rejuvenates the DNA of the skin. Green rooibos tea extract. There are many plant-derived antioxidants, and this is one derived from plants that grows exclusively in South Africa. It has been shown to contain extremely powerful antioxidants. The unfermented leaves of the green rooibos tea have no caffeine, low tannins, and a unique aspartame, plus many other powerful flavonoids, including rutin, luteolin, and quercetin, which acts like vitamin C. It is more active and it does not become inactivated by exposure to light. Rooibos also contains iron, magnesium, potassium, fluoride, manganese, zinc, and calcium. Due to its strong antioxidant activity, rooibos has a role in decreasing melanin formation. Research suggests that rooibos may promote healthy, younger acting chromosomes. Now we move on to sun protection. These agents reflect or block most of the rays, even visible light, and they are opaque, inert substances. They are more effective in photoprotection than UV filters, but can cause a white film when used in cosmetic preparations. Titanium dioxide. The most important inorganic sunscreen is titanium dioxide, an opaque white powder. It is milled ultrafine for its use in sun protection creams. Titanium has the fortunate property of not being recognized as foreign to the human tissue, so we can believe it can be used with safety in people who react against other UV filters. Titanium dioxide is available in different particle sizes. Larger molecules produce a whiter film when applied to the skin, while smaller particles produce a more translucent product. Although white film on the skin is aesthetically less peeling, it offers more UVA and UVB protection. Zinc oxide. Another very important sun reflectant is zinc oxide, which also has other benefits on the skin. Zinc oxide is probably the best sun reflectant because it provides good protection of UVA rays. One of the disadvantages when formulating the zinc oxide is that the pH is usually high, and antioxidants and active ingredients cannot be added as the efficacy will be compromised by that pH. It is important to point out that the whitening of skin after applying a reflective sunscreen is in fact a positive feature from the protection point of view. The whiteness indicates that an adequate layer of sun protectant has been placed on the skin. If you're going into the sun to play sports or hike in the bush, apply sunscreen that will keep your skin clear and make it appear a little white or gray. The most effective sun protection one can often see on sportsmen comes from thick pastes made from zinc oxide, which block out sunlight completely. Then we have our chemical sunscreens. Absorbent sun filters trap the energy of UV rays, which changes their own molecular structure. The sun filter molecule is then deactivated. Most filters absorb only UVB and not UVA rays. A few may be effective for both UVA and B rays, but in these cases, the effect is usually weaker protection from UVA. On the other hand, there are other chemicals that are partially affected only against UVA, giving minimal UVB protection. Many organic sun filters may become free radicals after inactivating the UV rays. Once a chemical has absorbed the UV energy, it becomes inactive and cannot protect the skin any further, but may in fact cause more damage if it has been absorbed. That is why sunscreen should be reapplied regularly, every 1.5 to 2 hours, so that we can protect the absorbed sunscreens as well as the skin. This is another reason why we need added antioxidants in the depths of the skin. For UVB protection, the oldest absorbent sun filters, but today also the most controversial, are the para-amino benzoic acid, or PABA group. PABA is effective in absorbing UVB rays. There is strong evidence that PABA may effectively prevent signs of sunburn, like reddening of the skin, but paradoxically may not prevent damage of the Langerhans cells or the immune cells, which are the most important cells for the maintenance of safe, healthy skin. Today, the most commonly used UVB protection ray is the methoxycinnamates, which have little activity in the UVA range. Methoxycinnamates may also become free radicals when exposed to UV irradiation, but their protection is greater than the potential free radical damage. For UVA protection, the best UVA protection available is found in newer chemicals that are stable when exposed to light. Tinosorb S and Tinosorb M give good UVA protection, and unlike other chemicals, are not inactivated or destabilized when exposed to UV rays. They are automatically recycled back into active state and do not become a free radical. Until the introduction of these ingredients, the best available UVA protection came from the butyl methoxy dibenzomethane related compounds, or Parsol 1789. The FDA has permitted their use in the USA, and the benzophenone compounds which were used in the USA are now being used less than before. Benzophenone is rarely a UVB absorber, which extends moderately into some of the vitamin A products, but most of the UVA is not absorbed. Benzophenone becomes a free radical when it absorbs the energy of the UV rays. At this stage, we believe that dibenzomethane compounds also become free radicals when exposed to prolonged sunshine. Not enough is known about the long-term effects of organic sunscreens, which we know are absorbed. Scientists are not sure what happens after exposure to them for many years. They have not yet been used for long enough to know what the effects after 30 years of exposure might be. Peptides. Arginine. Arginine provides milder but similar results to those achieved with the use of Botox. The resulting relaxation of the facial muscles is similar to that of Botox, but without the potential side effects of this toxin. In comparison, it lasts longer, is less expensive, non-toxic, and there are no needles involved. It effectively reduces the depth of wrinkles on the face and helps prevent the formation of new ones. Muscles are contracted when they receive a neurotransmitter released from inside a vesicle. The SNARE complex is essential for the neurotransmitter release at the synapse. The SNARE complex intervenes in the process of docking, fusing, and exocytosis of this neurotransmitter-filled vesicle. Arginine competes for a position on the SNARE complex, thereby modulating its formation. If the SNARE complex is destabilized, the vesicles cannot release neurotransmitters efficiently, and therefore muscle contraction is attenuated, preventing the formation of lines and wrinkles. Matrixyl is a synthetic combination of 7 natural amino acids, which when compared to retinol acts just as effectively, but has the advantage of not inducing skin irritations or reactions. It stimulates the DNA of the fibroblasts in the skin to create collagen 1 and 3 and builds up more elastin fibers in the dermis. Domaxyl rehydrates the skin by improving the ceramide activity in the skin, assisting in the prevention of DNA damage and reducing the reduction of sun-damaged cells. It improves the collagen production and elastin production, which helps to plump up the skin, thereby reducing the depth of wrinkles and fine lines and giving the skin a smoother appearance. Domaxyl is a combination of 6 natural amino acids that are found in the body and therefore not likely to cause any allergic reactions. Lufazole is an enkephalin that provides a modulation of acetylcholine release from neuron cell cultures. Lufazole couples to the enkephalin receptor on the outside of the nerve cells. Enkephalin molecules docking on these receptors result in the release of proteins that close the calcium channels and open potassium channels. Preventing the entry of calcium into the neuron avoids vesicle fusion, consequently inhibiting acetylcholine release across the synapse to the muscle. When Lufazole couples to the receptor, a cascade is initiated inside the neuron that results in a decrease of its excitability. That is, the nerve cell activity is turned down, and the release of acetylcholine is modulated. Muscle contraction will be relaxed, and therefore expression wrinkles will be diminished. Lufazole complements the actions of arginine. Vialox contains an active pentapeptide and acts at the most synaptic membrane. The peptide is a competitive antagonist at the acetylcholine membrane's receptor. As the acetylcholine receptors are blocked, the ion channels remain closed. There is no uptake to the sodium ions, and the muscles stay relaxed. Preservatives. Grapefruit seed extract has been deemed as a natural preservative. It is a broad-spectrum bactericide, fungicide, antiviral, and antiparasitic compound. Tea tree oil, the oils extractive, have 120 elements that can be used medicinally. It is well known for its antimicrobial activity and it's active against 39 separate microorganisms. It also aids in healing and repairing. Citric acid, widely used by chelating with metals and to adjust the acid-base balance. Parabens. They are derived from the processing of petroleum. They're very useful against mold and yeast, and less so against bacteria. There are very few allergic reactions to them. Almost all problems occur on skins with a compromised defense barrier system or history of allergic contact dermatitis. The use of parabens remains highly controversial, and after much study, parabens are not yet officially been deemed or listed as endocrine disrupting chemicals by any government, medical, or regulatory board. It could be argued that individuals or companies that market natural or preservative-free may foster support for such controversy, and may be doing so as part of their marketing agenda, rather than genuine science. Acids and enzymes are natural organic acids, and they're either grouped as alpha or beta hydroxy acids because of their molecular structure. AHAs are also known as fruit acids, although many of them are not derived from fruits, as an example, glycolic and lactic acid. Glycolic acid actually comes from sugarcane and is not a fruit acid in the true sense. Lactic acid comes from milk or fermented sugarcane, whilst malic, pyruvic, and citric acids are derived from fruit. Alpha hydroxy acids and beta hydroxy acid are peels based on weak carboxylic acids found in nature. Allergic reactions to them are extremely rare. In the case of alpha hydroxy acids, the presence of an OH combination on the first carbon atom after the carboxylic acid causes a softening of the acidic effects. In the case of the beta hydroxy acids, the OH combination is on the second carbon atom after the carboxylic acid, and as a result, the acid is somewhat stronger than an alpha hydroxy acid. Lactic acid is very likely the most common alpha hydroxy acid and most important. In contrast to glycolic acid, lactic acid is a very important part of our normal physiology and is an important part of our skin, hair, blood, muscles, and other organs. Humans manufacture about 120 grams of lactic acid every day. Lactic acid is found in two forms: L-lactic acid, which is the natural human form of lactic acid, or D-lactic acid, which is the mirror image of the natural lactic acid. And synthetic lactic acid consists of a mixture of L and D-lactic acid. It is important to understand that natural lactic acid is a metabolized faster by cells when used on the skin. It causes less irritation and softens hard hyperkeratotic skin. When one examines the effects of lactic acid on ceramide production, D-lactic acid has minimal effects. Synthetic lactic acid has moderate effects, and natural L-lactic acid has a very impressive effect at the same dose. This is important because the ceramides help to make the skin more flexible and improve the stratum corneum barrier function. The increase in ceramides is moreover important in treating dry skin in winter, when the natural level of ceramides drop. In 1996, a study of the therapeutic value of L-lactic acid compared to D-lactic acid, glycolic, malic, and citric acid. L-lactic acid was significantly more valuable than the others. Natural lactic acid has an important function in reducing pigmentation by suppressing the formation of tyrosinase. It works well with other tyrosinase inhibitors like vitamin C. It is also antimicrobial and, as such, is a natural preservative. Glycolic acid is synthetically made for all cosmetic preparations, but in nature it's derived from sugarcane. Synthetic offers greater purity and quality, and it has a very small molecular size. In low percentages of between 2 and 5, it has shown progressive weakening of the cohesion between the bilayers and corneodesmosomes, assisting in a uniform exfoliation of the stratum corneum. At this percentage, it's been shown that the skin will not be compromised. Mandelic acid has dual activities including antibacterial and exfoliating. It is suitable treatment for non-inflammatory grades acne 1 and 2, and inflammatory acne grade 3. It's a larger molecule size, may be why it shows less negative side effects. It slows penetration, keeping it on the surface of the skin, and saturating effect, similar to lactic acid. Citric acid, extracted from citrus fruits or made from fermented sugar solutions. They may function as chelating agents or pH adjusters. The salts may function as buffering agents or as a fragrance. Malic acid is an intermediate in the skin's Krebs cycle, as is citric acid. Tantaric acid occurs naturally in many patients, especially grapes and tamarinds. They are used as pH adjusters. BHAs break up the bonds between the dead cells of the horny layer. This facilitates exfoliation and allows for new skin cells to emerge. Another important effect is that the horny layer becomes more permeable and agents can penetrate the skin through this lipid layer. Salicylic acid removes the excess horny layer very efficiently and can penetrate down into the depth of the epidermis. It penetrates through pores, helping to restore the normalized and irritated skin around the pore, and lowering the pH, inhibiting the growth of bacteria on the surface of the skin. Phenol is the most toxic of agents used for peeling and has been the cause of death in a number of patients. While the smoothing of the skin can be impressive, the side effects are significant, with pigment loss being the greatest danger. It seems that phenol peels actually destroy melanocytes that produce melanin pigment granules. The paradox is that immediately after the peel, one may get excessive or hyperpigmentation that gradually fades into D or hypopigmentation. Phenol peels are deep peels, and as a result, the whole of the epidermis is damaged and has to be reconstructed from the sideward growth of the keratinocytes from hair follicles and sweat glands across the raw dermis. The result is that the reader pegs are destroyed and are never properly reconstructed. For this reason, the skin several years after the peel is thin and waxy and shows a fine wrinkling when it's pressed. Resorcinol. This is a popular agent used for peeling. It has a long history, but has problems. Because some people are extremely sensitive to resorcinol and may experience adverse side effects. Fortunately, this is uncommon, but it's important to do a small patch test before treating clients with resorcinol. Trichloroacetic acid, or TCA, is a man-made compound based on acetic acid. In order to make the acid more active, 3 chlorine atoms substitute the 3 hydrogen atoms. The advantage of trichloroacetic acid over phenol is that it's very safe, and allergic reactions or serious medical complications have never been described. However, this is strong acid, and deep destruction of the skin can produce with resultant scarring. Complications occur when concentrations over 20% are used. Some other peeling agents, we have the retinoids. Retinoids are in fact not peeling agents, although retinoic acid is considered by many to be an exfoliant type of treatment. The exfoliation is just secondary manifestation of the physiological effects of the retinoic acid. Retinoic acid in itself is a weak carboxylic acid. Retinoids are essential for preparing the skin for peeling. Enzymes are historically used in clinical treatments, and they are derived from papaya and pineapple, although more modern is synthetic. It offers immediate solution because the cells is immediately digested. Generally, there is no waiting period that's typical of the alpha hydroxys. Some controversial actives. Kojic acid is a well-known acid to the Japanese because it's involved in the making of sake. It is a weak acid with a pH of around 5.5 and does not easily dissociate into acid and base ions. It has no value as a peeling agent, but in the initial phases of treatment it may cause some exfoliation. It is of value in helping to stabilize the melanocyte during the post-peel phase so that hyperpigmentation is less likely. Kojic acid is not an alpha-hydroxy acid, but is often used in conjunction with AHAs. It is well known to the Japanese because they use it in the manufacture of sake. It is also an important part of the Japanese health diet. Kojic acid is a derivative from fungi and has been shown to be a free radical scavenger. It also reduces the excessive release of free radicals from neutrophils or white blood cells, but facilitates phagocytosis, the swallowing of bacteria by the neutrophils. When neutrophils attack bacteria, they release free radicals to kill the invading organism and then swallow the cells and break them down. Therefore, kojic acid promotes the immune system. Kojic acid also has some antifungal activity. Since 1988, kojic acid has been used in many skin care preparations. Several years ago, the addition of kojic acid was hailed as the wonder drug for pigmentation. Research has shown that kojic acid inhibits the catecholase activity of tyrosinase and thereby prevents the production of melanin. However, the magnitude of improvement is not always high enough. Experience has shown that high doses have to be used in some cases to treat hyperpigmentation. One point of concern is that kojic acid has been shown to cause fragmentation of DNA. It is believed to be a potent sensitizer of the skin, and this may take up to 12 months to manifest. However, skin irritation is not a common problem in people who make Japanese sake who come into contact with kojic acid daily. They tend to have beautiful unmarked hands even when they are old. Hydroquinone is a common industrial ingredient, and it's still widely used in the US and Canada markets despite being banned almost everywhere else. Long-term and incorrect use will cause cellular necrosis and pigmentation. The cytotoxic effects are not limited to the melanocyte, but the entire skin structure. This disorder is then characterized and progressive darkening when the product is applied. Histologically, it can cause degradation of collagen and elastin fibers. Thank you for joining me today for our presentation of cosmetic ingredients.